So today's discussion topic is capacitor. Capacitor is basically a device. It is a device used to store electrical potential energy. So you can mention in your definition that capacitor is a device used to acquire charges and store electrical potential energy in the form of electric field. Capacitor is basically made up of two plates or two conductors, and in between the two plates, in between the two conductors, there will be either free space or any medium may be present. So first of all, let us take two metallic plates. These are two parallel plates. It's a three-dimensional plates. When we provide charge on any of the plate, then the charge will reside at the surface, as we have discussed earlier. So charges will acquire on this plate, but this plate is at a distance from the first one. So from induction, if it is positive charge, the negative charge will shift here and the positive charge will go to that side. This is not open circuit, rather we are connecting it with a source. The source is not visible here. You may apply some potential difference across the two plates, and that's why charge will develop on the plates. This one is the symbol of parallel plate capacitor or a capacitor. The two parallel lines, these lines are showing area, and the separation between them is D, we are supposing it, and the gap between the two plates is filled with free space. So this one is the symbol of capacitor. When we provide charge by using any source, that charge will develop or charge will acquire on both the face of the first conductor. Due to this, negative charge will appear on the second conductor, or we can say first phase of the second conductor, and equal amount of positive charge will appear on the second phase. These charges are basically coming from its own. This is uncharged capacitor or uncharged conductor. So uncharged conductor does not mean there is no charge, rather the equal and opposite means equal amount of positive and negative charges are there. That's why it is showing neutral. So negative charge will be attracted towards this positive charge, and the positive charge will repel it. That's why they will form a bond character. So this positive and this negative will be attracted by each other, and that's why an electric field will start flowing between the two plates. Since the gap between the two plates is totally free space, so field intensity developed here can be denoted by E0. You know from Gauss theorem that when one plate is positively charged with certain surface density, we know from Gauss theorem that if two thin plates are there and they are having surface charge density positive sigma and negative sigma, then the field intensity in between the two plates, due to this, it will be sigma by 2 epsilon naught. Due to positive it is repelled, and due to negative it will be attracted by sigma by 2 epsilon naught. So net intensity in between the two plates becomes sigma by epsilon naught, and this is called field intensity between the two plates, those which are oppositely charged. Similarly, we can say that if there is a field intensity between the two plates, its magnitude will be sigma by epsilon naught and will be directed from positive plate towards negative plate. Now, this is all about the capacitor. But there are different types of capacitor. But before going to the different types of capacitor, we must know here a basic concept that the charge which we supply on any of the plate, if we are providing charge on this plate, this will be named as collecting plate. And the second plate, which sometimes we earth, this plate which we earth is called condensing plate. Remember, as long as you are not earthing the second plate, the name of the device will be capacitor. As you earth it, the name slightly changed and now it's called condenser. Condenser and capacitor both are same, but you call condenser when any of the plate is earthed. When you earth this plate or this face of the plate, then you know that earth, this is the sign of earthing. The earth is supposed to be having large number of electrons, so electron will shift from this place and will neutralize the charge present here. So finally the figure becomes now there is positive charge on this face and negative charge will not go in earthing. So negative charge will remain. So finally the figure will become like this. This shows that electric field is continuously acting between the two plates with magnitude equal to sigma by epsilon naught, depending upon the surface charge density of the individual plate. We were discussing about the different types of capacitors. One is parallel plate capacitor, in which two metallic plates will be there, or sometimes to minimize the cost, we make a provision of different materials also, but should be conducting in nature. So, this two plates are parallel to each other, again separation between them is there. It is called parallel plate capacitor. These two are again, the nature is spherical, the spherical plate capacitor. Third is cylindrical plate capacitor. In every figure you are observing that we are providing charge on one plate. This is the inner plate on which we are providing charge. This one is inner plate on which we are providing the charge. Due to this part will have negative charge. This part will be negative. Inside one is negative. That means inner face of the second plate will have negatively charged. And the farther face is earth. That's why the charge, those who are at the farther face, will be automatically grounded. So these are the three different types of plates capacitor, which are according to the dimension, not on the basis of the material present in it. But in all the three cases, still we are taking a free space. We can change the medium between the two plates also. When we change the medium, in that case we will discuss what will happen to it. As we have discussed, the two plates are here and these two plates are connected with a source. So different plates will have different potential. Let this end as having potential V1. This plate has potential V2. So V is basically V1 minus V2. This V means V1 minus V2. If this part is earth, then this becomes 0. So V1 minus V2. In this case, for example, this part is earth, so potential of this end you can take as 0. So whatever the potential it will have, the same potential will be in between the two plates. Now, the two plates means the plates are very similar to this. The plates are there. One plate we are providing charge, another is accepting the charge. When we provide charge on any of the plate, you all know that electric field in between the two plates will be equal to sigma by epsilon naught. Now, if you are providing charge, the capacitor will store electrical energy. If the capacitor is basically storing electrical potential energy in it, then the capacitor must have some capacitance known as electrical capacitance. How can you define electrical capacitance? The capacity of a capacitor to store electrical potential energy in it is known as electrical capacitance. How will we find out the electrical capacitance? So, when we provide charge, that charge will be directly proportional to potential difference. We know it. If we replace the proportionality sign, we are bound to use some constant. That constant is here. Actually, this is known as constant 2 and also known as capacitance. So this is the capacitance of capacitor. You may call it capacitance or you may call it capacity of capacitor. How will we calculate it? We can calculate it in this way. Suppose the electric field between the two plates is sigma by epsilon naught. How will you calculate the potential difference between the plates? That will be equal to field intensity acting between them and for what distance it is acting. You know the formula B equal to E into D. This means it is sigma by epsilon naught into D. So, capacitance, when there is free space between the two plates, this is equal to Q by V. Q will be equal to surface charge density into area of the plate, and V is equal to, this means this is the formula for capacitance. In this part, what is the difference between these two formulas? This is the basic formula that capacitance is directly proportional to charge and inversely proportional to potential difference, which we are observing, but capacitance does not depend upon charge and potential difference. Capacitance is basically a constant quantity. If anybody asks you to plot a graph between Q and V, you know Q is directly proportional to V, so you can directly plot a graph like this. So capacitance is basically the ratio. In this formula, you can define that the capacitance is the ratio of charge to that of potential difference. But capacitance does not depend upon charge or potential difference. Rather, capacitance depends upon the two terms. So capacitance basically depends on nature and dimension of conductors. Nature, what kind of materials or what kind of medium you have placed between the two plates, that is called nature. And dimension means area of the plate and the separation between the two plates. These two terms comes under dimension, and whatever the medium you have kept between them, that is called nature. If the free space is here, the formula will be this one. If you are having some medium in between the two plates and the medium has dielectric constant K, then the same formula in medium will turn into epsilon A by D, because you are putting some medium. If you put the formula formula of epsilon, then that comes out to be epsilon naught A by D into epsilon R. That epsilon R is also called as dielectric constant. This means you are observing that this part is C naught. That means in medium, capacitance is increased by K times. Of this medium. If the medium between the two plates is totally filled with some dielectric constant, its capacitance will be increased K times. This you can also understand in this way, that if two plates are there and the separation is filled with some medium having dielectric constant K, what will be the field intensity between the two plates? Definitely in that case, it is filled with some medium, so field intensity becomes not sigma by epsilon naught, rather it is sigma by epsilon. So here from you can also understand that the same formula, potential difference between the two plates, is equal to field intensity into separation. The separation is totally filled with medium, so you can go for capacitance in medium. Again, the surface charge density is sigma, so sigma into A, and D becomes Em into D. Em is equal to sigma by epsilon naught into epsilon R into D, which means this comes out to be epsilon R into epsilon naught A by D, which comes out to be K into C naught.